EDIBON is a company dedicated to designing and manufacturing technical teaching equipment for higher and vocational education and to the development of software applications as well. One of our most popular equipment units is the process control system known as UCP, indicated for the study of control variables such as temperature level, pH, or conductivity. Very practical when used with our software development kit, the ELK. EDIBON Software Development KIT is an open-source software package fully designed in LabVIEW environment. With this kit, a LabVIEW academic license is provided, allowing us to manipulate all the given codes, interact with EDIBON's units, and investigate new control algorithms, among other things. The ELK includes a wide variety of examples for signal acquisition and processing and for written or practical guided exercises which serve either for LabVIEW learning and training, to manipulate EDIBON's units, and to work on specific toolkits that reinforce the theoretical aspects in each area. An exclusively designed industrial SCADA architecture is provided to have full equipment control. Today we're going to create, in just a few steps, a program for level control thanks to the VIs included by EDIBON in the ELK. First, we create a new VI and we introduce it in the project. Next, we add a while loop that will allow us to control the program. Using the quick drop tool, we search for the error cluster, put it in the front panel, and open the project to add EDIBON's VI for analog signal acquisition. We then create all the controls and indicators and wire them to the included elements. For a proper signal acquisition, we must apply gain and offset values with the purpose of scaling the signal to the desired unit of measurement, as well as configure the physical signal to be acquired. To check it, we're going to open the valves manually and observe how the water level decreases. Once again, we're going to open the project and drag the VI design for the control of the analog actuator. We wire the VI and create the necessary controls. We can observe how the water level increases in the tank through the adjustments of the flow provided by the pump. Finally, we add the PID control developed by National Instruments, creating the clusters with the configuration constants of the PID, as well as a control to introduce the desired set point. We connect the inputs and outputs of the PID to EDIBON's VI. We include a graph to view the functioning of the water level control related to the set point value. This value is the level to be reached and maintained. To do that, we regulate the flow of the filling pump through the action calculated by the PID. As shown, using the ELK, you can develop control algorithms in a quick and easy manner without having to make modifications to the existing codes. Combining this powerful tool with EDIBON's equipment units, you will be able to invest your time in the study of processes and not in coding them. If you want to find out more about EDIBON Software Development Kit, you can contact us and check our website at www.edibon.com.